Okay, well here's the setup. I have my motor, which is my brushless DC motor made from a charger. And now I finally got this working. I don't know what I did to get rid of the problem that I had. There was some kind of distortion and it was freaking out, doing whatever it wanted to. But so if you come closer here, I'll show you the Hall effect sensors that I have on this little plastic hub that I made. And from the end, if you look real closely here, bring it up closer, you can see those shiny little magnets right there. There's 12 of those magnets. And on this little piece of cardboard, I have Hall effect sensors. One is here, and 70 degrees is the next one, and then another 70 degrees is the third one. And that's basically the same as having them 10 degrees apart, which would be easier, but because my magnets are so small and my Hall effect sensors are so wide, they won't fit onto the area of one magnet. So I had to do it that way. And well, here's the motor controller and the bridge rectifier, right? The three-phase bridge. If you come closer, just take a look at that. This is just my programming cable connected to the computer, and right here we have the 3 Hall effect sensor inputs to the microprocessor, and right here we have the MOSFET drivers, and here we have the MOSFETs on this board over here. So now, for right now, I've just separately connected 6 volts and about 1.5 amps, 1.6 amps to the rotor coil to make the permanent magnetic field on the rotor. And now I'm going to connect 12 volts to the controller, turn that on. It draws about 50 or 60 milliamps, so not very much. And this potentiometer controls the pulse width modulation, in other words the power to the stator through the MOSFET switches here. And I have this set at 12 volts, and this power supply can give 10 amps and it's not limited. And I'm going to connect that up now. And if all is still well, like earlier today, it should start spinning. Now if you take a look here at the current, as I turn up the potentiometer, oh wait, we have a problem here. Okay, maybe okay, so had a slight problem there. I forgot that whenever you turn on the computer the first time, if this is connected when you switch on the computer, it jams the reset on the microprocessor and then it doesn't start up. So that's why no power. Anyway, now if you take a look at the current, as I turn up the pulse width modulation, the current begins to go up. Now we got 50 milliamps and up to 100 milliamps, 200, close to 300. It usually starts to spin. There, just gave it a little nudge because the power is so low that it can just barely win its own friction to start spinning. And you control the power just by turning it up. So that's the maximum speed at 12 volts, and I can control that. As you can see, it has quite a bit of torque. And just bring that up to speed. Now if I bring up the voltage, and get it spinning a bit faster. And if I turn down the current onto the rotor, that of course decreases the magnetic field, creating the back EMF, which is limiting the current going in essence limiting the speed. So if I turn that down, the speed will go up. Of course, right now the torque is a lot lower because the magnetic field on the rotor is smaller. So you can get more speed, but then you lose torque. So it's a trade-off whichever way you go. My plan is to use about 2 amps, maybe a little less, on the rotor's coil, and I'm going to be using 12-volt batteries on the electric bike. And that won't give me very much speed out of the motor, but it has such good torque that I'm just going to put the chain onto a same size sprocket so that the gear ratio will be 1:1, or maybe even have it on a smaller sprocket on the bike's tire, so that, or on the bike's axle, so that the bike's tire will actually spin faster than the motor. It of course will require a lot of torque from the motor, but it seems to have enough. We'll see. But anyway, that's it for now. The first time I've been able to get it to work using the 3 Hall effect sensors. Here's a bit of the program. There's quite a bit here, so I'll just show you the main part. I have a while loop, and that just waits. If the Hall effect sensor 1 is, in this instance, off, Hall effect sensor 2 is on, and Hall effect sensor 3 is on, then I'll just loop right here for as long as those are on and keep it in this commutation step. And when the Hall effect sensors change, in other words the motor spins 10 degrees, it'll jump out of this loop and turn off all the power to the motor, and then it'll go into the next loop and stay there and turn on the power into the next commutation step and stay there until, again, it moves and the Hall effect sensors input changes, and then turns off all the power, and so on until we go through all 6 steps. And this is what the list looks like right now in the microprocessor. This right here means the first commutation step and the second, and so on. And there's 6 steps, and each 6 steps happens 6 times in a row per revolutions. So the motor's rotor moves 10 degrees, and that means that for one full revolution 36 times. So the commutation steps are repeated 6 times to get the 1 revolution. And that's about it. So enjoy. If you want to make a motor controller yourself, I'll be glad to help.